Okay, guys, so we have made it to our very last lesson of Math 9. This is all about probability, so I don't expect it to be very difficult. We're going to go over the two different types of probability and then some different practice calculations, and that'll be it. Okay, so first, how to recognize if a situation includes probability or not. So probabilities are any time where there is a chance that something could happen, but it won't definitely happen. Probability is the number of times something happened divided by the number of times it could have happened. So for example, 70% of drivers will text and drive. That means that 70 drivers text and drive out of 100 people who just drive, and therefore could have also texted. Or 1 in 5 people who take gravel don't get tired. Again, that means that one person took gravel and got tired out of 5 people who took gravel. All of them had the possibility of getting tired, but they didn't all get tired. Or 3/4 of TV shows only last one season, or I got 80% on a test. Those are all probabilities. Situations that don't involve probability are situations where there's no chance involved, where something either definitely happened or definitely didn't happen. So for example, if I just say we had 3 centimeters of snow today, like that happened. Or if I said, you know, what's the legal drinking age in Alberta? It's like, that's just a fact. So facts are things where there's only one possible answer. Probabilities are where things could but won't definitely happen. When you're expressing probability, you can write it as a percent, like 70%, or a fraction, like 3 out of 5, or in numbers, like 1 in 4 or 1 of 4. When you're comparing probabilities, you should always convert them into the same form. Fractions, obviously, we just convert by dividing the numerator by the denominator. So 3/4 gets converted into 0.75, and then you multiply that by 100 to turn it into a percentage, or 75%. If it's in words, like 1 in 4, that just means the first number divided by the second number, and again, times it by 100 if you want it as a percentage. If you're going the other way, if you're converting out of a percentage, you always just take the percentage and divide it by 100, and then you'll get a decimal. Okay, combined probabilities. That's what this little title is, calculating combined probabilities. This is when you have probabilities of 2 independent things happening at the same time. So for example, what are the chances that you flip a tail when flipping a coin and that your opponent chooses rock in rock, paper, scissors? Well, there is a 1 in 2 or a 0.5 chance of flipping either heads or tails. And then there is a 1 in 3 chance that your opponent picks rock, because rock is one of the 3 options. So all you do with combined probabilities is find the probability of each independent thing and then multiply them together. So 1/2 times 1/3 is just 1/6. Remember, we multiply straight across the top, so 1 times 1 is 1, and straight across the bottom, so 2 times 3 is 6. So try this next example on your own here, and then come back for the answer. Okay, so for this example, it says your friend is holding 4 straws, one is shorter than the rest. What is the probability of picking the shortest straw and then rolling a 3 or 4 on a dice? So the first fraction that I have here, the 1/4, is the probability of picking the shortest straw. There is 1 short straw out of 4 total straws. And then my second fraction here is the probability of rolling a 3 or 4 on a dice. So it gives us 2 possibilities, the 3 or the 4, out of the 6 different sides of a dice. And if it doesn't tell you how many sides are on the dice, assume it's a normal 6-sided die. And then we just multiply straight across the top, we get 2, straight across the bottom, it gives us the 24. And then of course we always need to put our answer in lowest terms, so that is 1/12. You could have also, if you wanted to, put this fraction in lowest terms before you multiplied, and that would have given you the answer in lowest terms. But I usually just wait till the end to do that. Either way is fine. So when it comes to comparing different probabilities, you do want to make sure that they're all being expressed in the same way. Usually a decimal is the easiest thing to compare things in, I find, or a percentage where you have whole numbers. So let's look at this example here. It says, which type of precipitation is more likely? A 12% chance of rain, a 1 in 8 chance of snow, or a 2 in 9 chance of hail? So 12%, which I could also write as 0.12, and then 1 in 8, if I just do 1 divided by 8, I get 0.125, and then 2 in 9, 2 divided by 9 is 0.2 repeating. So now it's very easy to compare these values to see which one is the most likely. Obviously, it is the 0.2 repeating. And again, you could have all of these in decimal forms. You could have just left that as 12%. If I times this by 100, it would be 12.5%. If I times that by 100, it would be 22.2%. Okay, so that is the one that is most likely. If you were trying to convert them all into fractions, that would be much more difficult because not only would they all have to be in fractions, they would all need the same denominator. So it's much easier to convert them all into decimals or all into percentages. When you are going to be using these probabilities to actually make decisions, you do want to make sure that you identify any assumptions in that. So for example, if you're like flipping a coin, you assume that the coin's not weighted. If you're trying to figure out what the chances of your opponent picking rock in rock, paper, scissors, you assume that they don't have a predisposition to like always picking scissors or something like that. If you have 2 equally matched teams playing a best-of-5 tournament against each other, you might calculate each team has a 50% chance of winning, but you're assuming that there's like no home team advantage and that all of the players are healthy and stuff like that. Okay, experimental probability. This is when we calculate the probability by actually doing trials. So we talked about this the other day with data collection when you would likely experiment. So if you were trying to figure out how often buttered toast lands butter side down, you would do an experiment on that. So you might just take a piece of buttered toast, drop it 50 times, see how often it lands buttery side down. If it lands on the buttery side 37 times, the experimental probability would be 37 out of 50, which is 74%. So that's kind of the easier type of probability. You just check something over and over and over again until you have a large enough sample size, and then figure out how many times did it meet a certain criteria. So for example, if I was trying to say, you know, how often does a box of whiteboard markers have a dead marker in it, I would just go through boxes and boxes of whiteboard markers and check all of the markers and see how often there's a dead marker in it, which, by the way, is very often. Theoretical probability is a little trickier. When you're doing the theoretical probability, you have to write down every possible outcome for a scenario and then count how many times your outcome came up out of the total possible outcomes. So for example, it says I have 2 jacks, 2 queens, 2 kings, and 2 aces. So 2 of each face card and then 2 aces in my hand. I want you to pick 2 cards at random. What is the probability of picking a jack and a queen? And so all I do is I list out all the possible options. You could have 2 jacks or a jack and an ace, or a king and an ace, or an ace and an ace, or whatever. List all the possible options that you could pick if you're picking 2 cards at once. And then there's one occurrence of the jack with the queen, which is what I was looking for. There are 10 possible occurrences. So your answer would be 1 in 10, or 10% probability. Okay, Let me know if you have any questions about this, but congratulations for making it through the last lesson of Math 9.